All right, I'm going to make a series of videos on each of the battery builds that I have, and I need to be a little bit specific of what I've done and what's in it. And this will be my first one, and so I'll do a little bit of a broader range and some of the mindsets of how I came to this. So I'd like to answer the question of why would anyone build a battery, build a battery using the case of a toolbox. So for me, when I go to work, I'm usually having tools with me, toolboxes. It's something where we're strapping down, tying down. When I go camping, it's kind of the same mindset as well. I need something that I can pick up and I can put in. It's going to be in a case. It's got to be durable. I don't want any exposed terminals. I don't want to have taken a traditional battery, lithium ion one, and having to reassemble my battery bank. It was taking hours to do that, and I only get to camp a little bit at a time, a week or two. So to set up, to take apart, to set up, to take apart. The mindset also is if this is flexible enough that I can take it into the basement in case of emergency, that's where we are to go. Making sure that we have that 3-day preparedness. So, water, food, and then this will keep our DC fridge charged up and phones charged up. So multi-purpose. Definitely, I'm kind of in between the areas. You have those all-in-ones. And now all those ones are nice and small. They won't give me the capacity that I need. This is a 6.7 kilowatt hour. And some of the larger ones that have this kind of capacity, they also have an inverter based into it. And now we're talking over 150 pounds. So for me, I look at this as a tool. It's the same as you would as a cordless drill. You have the battery that you slide in, and once it's used up, you pull out. And what I mean by pull out, I bring it back home, or I'm taking it to a generator and charging it up. The capacity of this battery is really, when we started with lithium ion there, those were purchased in 2015. If anybody knows what became of Start Power, please leave me a comment. That is 120 amp hours, and this is 650 amp hours, or 560 amp hours. Quite a bit of difference. There's 5 times the size. And now I'm not having to worry about polarity. I'm not worrying about series or putting things in parallel and all the cables that are needed. Everything's kind of self-contained. And the more I can do with an Anderson, the more I can do with an XT60 as opposed to loose cables, the better I am, and it's the safer I am. So for work-wise, we've gone this direction because we used to run the generator, but at night we can't keep the doors open at night. We don't want all the cables on the floor because that's what we're working on, whether it's sanding or whether it's refinishing it on the waxing. And we were constantly just flipping breakers because these use all the 15 amps to 20 amps. This has changed that quite a bit. And when I first started with my trailer, I didn't have much for solar. So I would use the battery as a way to store the energy instead of just letting the generator run 24/7, which drives me crazy when I'm at a campsite. So I've been able to contain everything into this kind of a format where I can pick up, throw in the back of the truck. This is 2 years of camping. This is 3 years of work. So it's been in the back of the truck or the van several times. Other people have been handling this thing, and it's definitely doable to go down flights of stairs. I think it's, with me standing on it and things like that, it's extremely durable. We're within the weight range of this case itself. And then regarding the inverter that you run, I don't want the two to be combined. If the inverter goes out, generally they don't last a long time. The low frequency is supposed to last longer, but I've got lots of high frequency ones that we've burnt up and used up. But I have some others that are same age as that battery. It's going really good and we use it every day. I would hate though to have to throw out an all-in-one because the inverter has died. So we're looking at these cells inside here is the same mindset as this, where we've got it protected, encased. We have the rods to keep the cells stationary in the case. There's, I want to call it crush zone like a car, but yeah, that's what it is. You have some, if it fell out of the back of the truck, it would probably survive fairly well. I don't know if I would crack the case or not, but it wouldn't be the end of the world because you can replace the case. So when you pop this open, flip it open, I've got lights in here because anytime that something's gone wrong, it's going to be in the middle of the night. We have a main fuse and we have secondary fuses for all the ports. We also have a battery protection. So that kind of leads me to the BMS. And on the BMS side, there's two BMSs. And all my builds, I'm trying to have redundancy. I'm trying to have a fail-safe. I'm trying to have a second way that in case something goes wrong, things go sideways, there's a way we can shut this down. This has been designed as from Victron as a battery protect, but on the low voltage side, but it can also be done as a high voltage because I can send a signal to it, and that signal I can do the same if I want to do with a MPPT, if I want to do with an inverter, and that signal is just basically an open or closed circuit. So very, very straightforward, very easy. And the important thing I think is that it's telling the component to shut down. It's not the BMS just disconnecting the load. It's actually telling the device, you have to shut down. And it's the device that does the shutting down instead of that. It's going to get a shock. It's going to get some kind of a shock as it just disconnects. If you're charging the batteries or discharging the batteries at 100, 200 amps, that's a shock to the system. Having the equipment run and pulling the cord out of the wall, it's a shock to that motor to it. So it's not good. Now, a typical BMS will be using MOSFETs, and that continuously cycling like that is going to shorten the life of that. And when it fails, when's it going to fail? You don't know. So having dual BMS is definitely the way to go. Safety wise, when you hear fires breaking out because of electric bikes, maybe it's because of the port BMS, but for sure it's only because there's only one BMS to it. Maybe someone's been playing with the settings, and maybe it's not the BMS's fault or the designer's fault, but there's a lot of times where the BMS companies are not letting their end customers, adjust the BMS simply because of the safety part of it, and rightfully so. So this first BMS is set for, I'm thinking it's probably at the 3.6 ratio. The other one is set for the 3.65. And there's a third step I have for safety on that. So when this gets too high of a charge, so it's charging up the battery for the MPPT, it'll tell it, hey, one of my cells is getting too high. I'm going to disconnect that load, or I'm going to tell the inverter to shut down. And I want it to do that before the fail-safe to do it. So the fail-safe, which is a actual relay base, 200 amp relay to it, it will maybe never get used. And that relay can be replaced. That's, they can go up to 800 amps or higher. Of course, I have to work within the case size. This one is based on 200, but the wear and tear on that should be almost none, because this is the one that's telling the devices when to turn off. And this one should last a long time because it doesn't do the heavy lifting. it's just sending a low wattage signal to the devices to turn on or turn off. Now when I put this into my trailer, I strap it down, and that's another good sign that the case is really quite durable, because I can ratchet that down and it's not going anywhere. And my mindset now is going forward is, because it would cover that screen, so I usually lay a cover on it. It hasn't been really much of an issue because I'm using the Wi-Fi based out of it, and so I can view it on my phone or on the computer. But going forward, I do want to do it this way. And then this way, even when it's strapped down, I still have access to the screen. And of course, if it's on the floor in the cargo trailer, it's, then it's a lot more viewable. Very nice color display. It's going to show you history, case history, and it's going to show you your wattage or your RN amps, and it's also going to show you your state of charge. And the more you use it, the more accurate the shunts that are in it become. So I'm going to just check my notes. Okay. Now, when we do open this up with the light inside, and I'm taking the time to make sure that everything's been wired nice and neatly, you'll be able to use the equipment here to view the cell's state of voltage, but I want to have you have the access with a voltmeter to be able to do the same. And then if a fuse has to be changed, I'm trying to use things that are like a car fuse, things that you can get at any hardware store. You have the ability to repair or replace. Hopefully this is just the start of where we're going with this technology. Obviously it's going to get better, bigger and better, and you can pull these cells out, use the same case, drop the new cells into it, and who knows, hopefully it'll be even double the capacity that this can carry, and maybe even lighter. But you have that ability. You're not throwing everything away. This is totally upgradable. The BMSs really won't change that much. They'll get better as well, but by and large, it's going to be always doing the same thing, especially like things like fuses or shunts. So the BMS that I have works with the relay, and I have this in series with the relay, so I can shut the relay off, and then it shuts power going out of the ports. So this is going to the part about the port. So if I turn this on, I am constantly on the search for what is the best USB or car charger. And so this is not the final product, and maybe you only want the one, maybe you want the two, or maybe you want one all the same, maybe just want just USB-C, but this can change. I recommend anything that you can convert to DC, that's the way to go. So, and also to eliminate those cigarette light chargers that go into these things, because they are not really that positive of a connection. And I will take it like to an XT60 or a small Anderson connection for that. So with that on, I'll just shut this light off to show you that. Now, over here, I've got a 175 amp Anderson. They're rated up to 250, and I've got it set up as yellow because I think that's what 12 volt are supposed to be. By and large, I use the gray. That's where I've started with all mine, but one day I looked up on the spec sheet and it was yellow, and of course this is a yellow case, so I thought, no, let's do it that way. And the nice thing with doing it different colors is that it gives me some safety, because I built 24 batteries and I need 24 volt inverters. So I don't want to plug, which I've done once, a 24 volt, a 12 volt inverter into a 24 volt battery, and that was the end of that one. So on this side, I have the Anderson, and this is my port for the communication. And then this will show us my last thing to show on this battery build. So I will hook this up, do a quick, just do a quick video of me running the power. This is kind of designed for that 2,000 to 2,500 mindset for inverter. The capacity, say if I didn't hook up to solar in my one trailer, you give me like 4 or 5 days on a DC fridge, which is using 50 watts. If I'm at home running my AC fridge through the inverter, I'm only going to get about 4 days. So DC is, and of course that's just running the fridge. But when I'm in my trailer, it's the microwave, it's the coffee machine, it's all the devices. No air conditioner, I would say you're going to be able to run on this setup, simply because you can only run about a 4-aught cable through this Anderson. So you're limited just strictly because of the size of the cable that you can run. And if you do want to run an air conditioner, I will show you, I will direct you towards some of my other builds that I have, okay? So, and I'm gonna, maybe this might be where I shut this video off and restart it, but I'm gonna try to just bring the camera over, and if I'm not too awkward, I'll just, I won't have to edit it and restart it again. Okay, so the inverter's still off. Maybe I'll put it here. Inverter's still off. Can I get everybody in the same frame? Okay, and you can see the light down there, so it's still off. So pop the cover. Okay, and I can't stress that enough. When I put this in my trailer, strap goes down, Anderson goes into, say, into the inverter, and then on the other side, that's going into my MPPT or my charger, and it's done in seconds. Well, before it was hours for me to set that up. And I'm doing it nice and safely because none of the terminals are exposed. I should say in the future, if anyone wants, since this is Electrodacus, I can also install or have say a 50, 60 amp MPPT built right into the device. So keep that in mind if that's what you want. Okay. All right. So it's not on. You'll notice when I hit this switch here, this light will turn blue, or the screen will turn on. I also need to show you, let's do that right now, how nice this screen looks on this Electrodacus. Okay. So in this case, it's showing me this is the individual cells. And then this will be the wattage it's using. I'm going to just leave this here as I turn the And that gives you an idea. Now, if you have a secondary shunt, you could also be able to say, have it separated. Show, separated of the power that's coming in. So, and then I want to show you case history that you can see that. So this will be a graph, and this will be a lot more, a little bit more information if you want it through the Wi-Fi through your computer. So I generally just use the app on my tablet or iPhone for that. Okay. Oh, that was the screen. Now, okay, so that, let's get the clamp meter going. So the device that turned on was the vacuum cleaner. Okay, now I'm going to zero it. All right, good. We'll put it to here. And I'll just scroll ever so slightly in. Oh, I just want to show you. Okay, yeah, that's on. I should be able to get, that looks good. Okay, so here's the vac. Okay, so now another reason why you get more flexibility with having your inverters separated from your all-in-one is now you get to decide what kind of inverter you want. Can you get away with just the high frequency? If you're just running a coffee machine or microwave, you bet. But if you're going to try to start a saw or an air conditioner or an air compressor, you need that, that inrush, high surge is the word I'm looking for. High surge or inductive load. So that's where you have to use a low frequency inverter. And of course, they're probably going to last a lot longer. But if you had these two combined, you'd be at 130, 140 pounds, which is impossible. I want to be able to carry it down the flight of stairs, or be able to pick it up with hurting my back, put it in the trailer, and doing that, 2 or 3 times, 4 times in a year. All right. So vacuum cleaner. I'm gonna do the skill saw a couple of times. I really want you to see the inrush or the this high surge load. So we're almost at 180 amps. I hope you can see from my trigger, pulling of the trigger, do it starting. There's no lag to it. There's no trying to start. Now we'll turn the vacuum cleaner on. Okay. And this is maxing out this inverter. That was like 280, and that's definitely maxing out this inverter. All right. Now the last thing I want to show is this third safety feature I have. And this comes from my frustration. I thought this was important. Even though I have 2 BMSs, and that's going to be more than probably safe enough, I still am not satisfied that that the lead, okay, let me start again. And I might have to restart this whole video again. All right, I'd like to now give the direction I have for this port, and it's a 5-pin, and if it was a 24 volt, it would be a 9-pin. The problem with fully charging a lithium battery is that each one of these cells is a 3.2 volt battery. And if you want to think in watt hours, that's kind of close to what one of these is. So if we can imagine 4 of these put together and charging them from the same charger, could we get all 4 batteries to hit fully charged at the same time? And that's a nope, nada. And that's why balancers are used. So the one in this battery, the backup BMS, it has a 5 amp active, and it will take power from the highest cell and put it to the lowest cell. And it works okay, but it is slow and a little on the scary side, because when you balance or fully charge a battery, the BMS on most batteries has the setting, the high voltage disconnect or stop charging setting, set around 3.65 volts. And when the balancer has lowered that high cell and given that power to the lower cell, so now we're back, we've gone from 3.65 to say 3.45, the charger is allowed to turn on again. And yeah, that does work. But the unsafe and why it's so slow is because the charger isn't being told to lower the amps. It's full on.
So maybe you have a 30 or a 60 amp charger. Well, that's always what it's at. So it's always it. So you can think about that abrupt start again. So it's on again until that cell hits a 3.65 volt, and then BMS just disconnects the load, and this is a cycle that goes on and on. And anything along that chain of charge or discharge, it can't be doing it any good. If the cycle takes that's like 3 to 10 minutes, I would say. And most times when you want to top balance a battery, that's going to be anywhere from 8 to 24 hours. And once I had a charger try to take 2 days to top balance a battery, and I just gave up. So that 100 times of flirting with 3.65 volts, you just can't go over 3.65. That's what they're rated for, or you'll ruin the battery cell. So is there a way that we can safely and easily charge up a LiPo battery, just like we used to with the lead acid battery? And that's where this port comes into. So the reason a lead acid battery is so easy to charge, minus having to check the fluid levels, the two reasons was once you plugged it in, the charger was in charge. It would know the overall voltage and make adjustments to the charging amount accordingly. That's why there is a bulk, a float, and absorption mode. The charger would, let's say, read a low voltage of 12 volt. Start the charging, so that's bulk, and let's say it's at 40 amps. And then when the battery got to 13.8 volts, it would ramp down the charging to say 5 to 10 amps, and that would let the cells do the float or absorption, to let the battery do the float or absorption. And then sometimes we even do a smart charge would just keep about 2 amps, so that when the battery is fully at rest, it would still register at 14 volts. That's fully charged a lead acid battery. So let's take that same charger, or any charger that you have, maybe it's a lithium one, let's put an XT60 on it, and turn it into a smart charger. Not to be confused with something like this that says blue smart charger. Again, this is no different than a lead acid battery. It's only going to read the overall state of charge. We need, like that, the overall, which is at 11 to 15 volts. But we need to read each cell, ranging from 2.6 volt to 3.65. And whether it's a 4 volt, or a 12 volt, 24, or 48 volts. So 4, 8, 16 cells. This is a charge controller, and you can read each cell, and you can decide how close to 3.65 you want to be. Now for this application, it has to be lower than the other two BMSs in the battery. So this one here is set at 3.6, and the failsafe is set at 3.65. So I want this charge controller to shut off at not just to shut off at 3.55, but to slow the charge down to say when it hits 3.5 volts to just say 5 or 10 amps to allow the battery to float or absorb, and then to get all the cells up to that 3.55. And it also does have a balancer as well. I'll bring this up to the camera and give you a little bit of an idea. So it's reading at 0 right now. Okay, a little bit of a spin. Okay, so there's my cells. I take the 2 battery setting. I'll put this here. Okay, and I hope you can read that. 3.42. Now, this is either you can consider it like a DC to DC charger, but when you take your chargers that you already have, so that DC will go into this side. But I can take DC from another battery, and it didn't matter if it's a 24 to charge a 12 or a 12 to charge a 24. It don't matter. Now, settings, life pole 4, it doesn't, the condition means, it's a little, like a flag on a racetrack, but it doesn't ask me what the overall state of charge, like when you want me to end the charge. It's asking me what is the highest level that you want the cell to be at. And you can set that. I've got it at 3.55. Cells, it knows it automatically at 4S, and the current 21 amps. And then I just got hit start. Oops, start. And so it ramps up, and then when it gets to that 3.5, I'd say, it starts to slow down, slow down, slow down, slow down, slow down. Okay. And I have several of these, and not one of them has ever made a mistake. But again, if it made a mistake and went over that 3.55, maybe I have forgotten, I didn't set up the right chemistry on it or something, I changed it. Again, you still have this set up to your other 2 BMSs, and that would catch that. So all I can say is have a lithium LiFePO 4 set up and never adjust that, and then the only thing you're going to be playing with would say be the total, the high point of that 3.55. And the fan, as you can hear, it's not that bad. Okay, so that's 21 amps. It can go all the way up to 30 amps if you want. So the last thing I should say though, is with the Electrodacus, you can get chargers that that Electrodacus can control by that open or closed circuit. So it's and that's a really safe way of doing it as well. But again, it doesn't tell the charger to go into an absorb or float state or ramping the charger down. Again, it's just going to be fully on or fully off. Okay, no. One more thing I'd like to say is that an MPPT is a charger, and we can control it in the same way, and I'll show that in a future video. Thanks. How quickly can we tie strap this down? So this is the inverter. This is the remote on and off to the Victron Battery Protect, which the BMS controls by this communication cable. Open or close circuit. Okay, this is from the Victron. Okay, I'm going to turn the switch on here.
Okay. And if Colton wants to come over to here now. Okay, back up as much as you can. And you'll see this is on. I'll give you a quick test of the and 0. Okay, I hope you can see that it's making 7 amps. 6 amps, okay, 7 amps. Okay, we'll leave it there. Now we'll show you how the BMS will control this, and we'll shut this off when it feels it's high enough, because it does the at a cell level as opposed to the overall voltage. Same thing with the inverter, since the inverter doesn't know the status of each cell, but this does, and it can control this by the battery protect. So I'll just shut it off and I'll turn everything back on. So this is a way of testing. So I'll go to 0, 0. Okay. So you can hear that the inverter is charging off. If you want to get closer. Okay, now it's completely off. And if we come over to here, we'll see this is completely off as well. Okay, let's turn everything back on. Okay, and you'll see that this is ramping back up, 5 amps. And you'll see that the inverter, can you see the blue light? Is back on as well. Okay. Thanks.